Hello there, Nareg is here. Today I'm going to talk about how to study the sign of roots of a quadratic equation. So whenever we have a quadratic equation and it has roots, how am I supposed to find the sign of roots without calculating them? We need to check the sum and the product. In the previous video I already talked about the sum and product, so we're going to use it also in this video. So let's start. The general form of a quadratic equation, as you know, it's ax squared plus bx plus c, which is equal to 0. So this is a quadratic equation where a, b, and c are the coefficients. Now, whenever you're gonna solve this equation, you need to go through delta. So you have to calculate delta, which is b squared minus 4ac. After calculating delta, if delta was negative, it means that you have no real roots. Now, whenever delta is 0, it means that you have one real double root, and of course one real double root means x1 is equal to x2 is equal to minus b over 2a. And if delta was positive, you have two real distinct roots. Of course, in this case, we already mentioned about the formulas of each root. x1 is equal to minus b minus square root of delta over 2a, and x2 is equal to minus b plus square root of delta over 2a. Now, without calculating the root, how am I supposed to study the sign of the roots? I should check the sign of P, the product, and the sign of the sum S. In the case of delta negative or delta is equal to 0, it doesn't really interest me. It will interest me whenever delta is positive. So delta is positive, I have two real distinct roots. These two distinct roots could be positive, could be negative, could be one positive, could be the other one negative. So how am I supposed to study the sign? Very easy. So let's go and talk about this part. So whenever we have, if delta is positive, I have two real distinct roots. All right. Now, in order to check the sign of my roots, I should first talk and discuss about the sign of P. P is actually equal to C over A. Now, the first case, when P is actually positive. P is positive, it means that the two roots are from the same sign. Positive times positive, or negative times negative. So in order to find out if both are positive or both are negative, I should check the sign of S. S, which is the sum, is minus b over a. If the sum is positive, it means that the two roots are positive. I can write down as x1 positive, x2 positive. If the sum, which is of course minus b over a, is negative, it means that both of them are negative. x2 smaller than x1, smaller than 0. So once you have p positive, you should check your sum. The sum is positive, both of the roots are positive. If sum negative, both of the roots are negative. What if p was negative? So p, which is equal to c over a, is negative. Again, it means that one of the root is negative, the other one is positive. But of course, how am I supposed to find out more about them? I should check S, the sum. If the sum is positive, it means that the negative root in absolute values will still remain, which is x1, let's say x1 will remain smaller than x2, and I can write down x1 smaller than 0, smaller than x2. Now what happens if the sum is actually negative, in this case you will have again x1 smaller than 0 smaller than x2, but x1 in absolute values will be greater than x2 since the sum is negative. So x1 in absolute values will be greater than x2, so x1 smaller than x2, smaller than 0 smaller than x2. And what happens if the sum is equal to 0? So whenever the sum is equal to 0, it means that the roots are opposite. So in this case you can write down as x1 is equal to minus x2. Both of them are opposite. And the last case, if p is equal to 0, so the product could be positive, negative, and 0. If the product is 0, it means that one of the root, let's say x1 is 0, and the other one, which is x2, will be simply equal to minus b over a. So this is how you study the sign of roots related to a quadratic equation. Let's take examples. So let's start with some examples. The first example, I have 2x squared minus x plus 1, which is equal to 0. In this case, delta is equal to minus 1 squared, minus 4 times a is 2, c is 1, so it's equal to 1 minus 8. It's a negative value, delta is negative, so I can say no real roots. Since I have no real roots, and of course we're using the real numbers here, there's no need to discuss. You cannot study the sign of its roots. Another example, so what about this one? 4x squared minus 4x plus 1, which is equal to 0. So delta is equal to b squared minus 4ac. It's equal to minus 4 times minus 4 squared, minus 4 times 1. So it's 16 minus 16, which is equal to 0, which means you have one real double root. All right, one real double root, and in this case you can calculate the root. x1 is equal to x2 is equal to minus b over 2a, so it's 4 over 8, so it's 1 over 2, and that's it. You don't need to discuss about the sign of the roots. What about another example? Let's say we had 5x squared minus 3x minus 2, which is equal to 0. So delta is equal to b squared minus 4ac is equal to minus 3 to the power of 2 minus 4 times 5 times minus 2. So it's 9 plus 40, so it's 49. 49 is positive, so you have two real distinct roots. Without calculating the roots, how am I supposed to find out about their sign? Very simple. I will check the product. So the product, p is equal to c over a. P is equal to minus 2 over 5. P is negative, which means that x1 and x2 have opposite signs. One of them is negative, the other one is positive. How am I supposed to find which one is negative, which one is positive, and the difference between them? I should check the sum. The sum is minus b over a. Minus b over a, it's minus 3, it's 3 over 5, it's positive. The sum is positive, it means that the negative root in absolute values will still remain smaller than the positive root. So you can write down x1 smaller than 0, smaller than x2, and of course x1 in absolute values will be smaller than x2. All right, so this is how you discuss the sign of your roots. Of course you can calculate them. It's minus b, it's 3 minus 7 over 10, or 3 plus 7 over 10. 3 plus 7, it's 10 over 10, it's 1. So one of them is 1 and the other one is negative. So you can of course verify it. Let's take one final example. So what about this example? 3x squared plus 5x plus 1, which is equal to 0. Now in this case, again, I should calculate delta. Delta is equal to b squared minus 4ac. It's equal to 5 squared minus 4 times 3 times 1. So it's 25 minus 12. It's 13, which is a positive value. It means that I have two real distinct roots. All right. Now, how am I supposed to study the sign? Again, I have to check P, which is C over A. C over A is 1 over 3. It's positive. What do I mean by a positive product? Which means that x1 and x2 have the same sign. Both of them could be negative, both of them could be positive. Negative times negative, it's positive. Positive times positive, it's positive. So I should check the sum. What about the sum, which is equal to minus b over a? It's equal to minus 5 over 3. The sum is negative. So if the sum is negative and both of them have the same sign, so it means that both are negative, which means I can write down x1 smaller than x2 smaller than 0. All right, so in this case the two roots are negative. If you want, we can check them. Let's say x1 is equal to minus b minus 5 minus square root of 13 over 6, so it's already negative, and x2 is equal to minus 5 plus 13 square root of 13 over 6. Again, it's a negative value. All right, so I'm verifying that x1 is smaller than x2 and it's smaller than 0. All right, that's all for this video about the study of sign of roots for a quadratic equation. I'm going to ask you to subscribe to my channel. So once you subscribe, you'll be notified whenever I upload new videos. I can also share with you my Instagram or Facebook account in case you want to contact me, or you can simply leave a comment below. That's all for today. I hope it was helpful, and see you next time.